in this problem, I've got 3 bars that are in between 2 supports. Okay, steel, brass, and copper. Different stuff is given there for us. Okay, so if it's initially at 12, what happens when it goes up to 18? So they're going to want to expand. The problem is as they try to expand, it's going to push against the wall, and the wall is going to push back on it, and it's going to create a compressive force through those rods. Okay, so but because those rods are completely rigid, I know that the total delta has to be 0. So basically, the delta of the steel plus the delta of the brass plus the delta of the copper have to add up to 0. Now, each delta is not only the fact that they're going to expand with the change in temperature, right? But they're going to compress due to the fact that there's a force, a compressive force pushing it on there. So the expansion, it tries to expand out, but the force keeps it where it needs to go. Okay, so some of these might actually get bigger, some might get smaller, but the overall thing has to be 0. And for the expansion of each piece, we have to take into account both the thermal expansion as well as the mechanical compression due to the force. So let's go ahead and get started. We'll do it with steel first. Okay, so steel, we'll start with thermal expansion. Okay, we see that alpha for steel is 12 times 10 to the minus 6. Okay, delta T is 18 minus 12, or 6. We're going to call it 6 from now on. Okay, and the length of this guy is 300 millimeters. I will do that in meters as shown here. Okay, so that's what it's going to expand as it increases by 6 degrees. Now there's going to be a compression on it. I'm going to do the denominator first, where I've got the E for steel, which is going to be 200 times 10 to the 9th pascals. That's 200 gigapascals. Okay, and then the area is given as 200 square millimeters. Well, that's going to be 200 times 10 to the minus 6 square meters. Okay. My P is, again, the P, that's the compressive force that I'm trying to find, and L is 0.3. So that change in the steel, I can simplify to 21.6 times 10 to the negative 6 minus 7.5 times 10 to the negative 9th times P. Okay, so now we'll do the same thing for the brass. So the deflection of the brass is going to be, on this guy, is going to be 21 times 10 to the minus 6 times, again, 6-degree temperature change. This one's only 200 millimeters long. Now I do the compression due to the force. Not equals, negative. E is 100 times 10 to the 9th. A is 450 times 10 to the minus 6. Again, that's gigapascals, and then switching to square meters from square millimeters that was given. And then it's the same force going through all of them, so it's still P, and this one is going to be the length 0.2. So I can simplify this one a little bit, okay, and I get 25.2 times 10 to the minus 6 minus 4.44 times 10 to the 9th times P. Okay, so now we'll do the same thing for the copper. So the deflection of the copper, again, it's going to expand due to the temperature. Alpha is 17 times 10 to the minus 6. The temperature change is 6, and this guy is only 100 millimeters long. I'm going to subtract that. E on this one is 120 gigapascals, so times 10 to the 9th. And 515 square centimeters, which would be times 10 to the negative 6, putting it in square meters. And then again, it's the same force going through all of them, so that's going to be P. This guy is only 100 millimeters long, so I get that. So this guy then becomes 57 times 10 to the negative 6 minus 13.6 times 10 to the negative 9 times P. Now, again, whoops, I wrote the wrong, that's what the next guy equals. Excuse me, this one actually equals 10.2 times 10 to the minus 6 minus 1.62 times 10 to the negative 9th times P. Now again, adding these all up, I find that 0 equals, and this is where that gets, so if I add up the 21.6, the 25.2, the 10.2, I get 57 times 10 to the minus 6. And then if I add up those P's, I add up the 7.5, the 4.44, the 1.62, that's going to be minus 13.6 times 10 to the negative 9 times P. Solving this for P, I get that the force is 4.203 kilonewtons. So just raising that 6 degrees causes a 4,000 Newton force going through all of those members. And again, it's due to the fact that the increase causes it to want to, increase in temperature causes it to want to grow larger. The walls say not so fast, pushes it back with a force keeping it at 0. Okay, all that combination creates that internal force of 4,203 newtons.